my time is cut very, very short. Now, please remind me, I know we had a holiday, you may have been thrown off there. Last week, I think it was, did we do the sine and cosine graphs?
We did indeed.
And we did the domain, range, amplitude, period, and all that business. And then I think I was showing you a quick way to get to a graph without going through all those transformations, right? I think I called it bounding or something. I showed you one of those, maybe how you bound it.
Yep.
Okay,
Yeah.
so it looks like maybe, I'm checking here. Yeah, it looks like it is. Jacob, you're gonna be a favorite this semester since you're nearby here. You've read some of this for me.
Oh, no problem.
Section 5.4. See, let's read to the class so I can hear some of this vocabulary coming up, okay?
Graphs of the sine and cosine function vocabulary. Sinusoidal, relating to shaped like or varying according to a sine wave or sine curve.
Now stop there. So if you leave me, and all of a sudden you go into another class, and all of a sudden that professor starts using sinusoidal, and you'll say, Professor Ramsey never use that. What is sinusoidal? I see sine or hear sine in sinusoidal. Then he's describing that as it pertains to sine.
So,
Also cosine.
yeah.
Cosine itself has the word sine in it. And sometimes they'll use the word sinusoidal, so if they do, you know they're going to deal with a sine or a cosine graph of some sort. Tell us more vocabulary.
Amplitude,
We know what amplitude is, okay?
period or cycle,
Okay.
and phase shift.
Now the phase shift. I thought I'd bring that in just in case you leave me and another professor, rather than saying horizontal shift on one of these trig graphs, they'll say phase shift. It's the same as horizontal shift. Okay, they just like to use the words phase shift when they do a trig, okay? And then I think I have only one example here at this point to graph,
Yes.
okay? Now I'm gonna graph it with the techniques I showed you guys last week. And then all of a sudden underneath there, some students emailed me and said, Professor, I've seen the textbook or I've seen in a previous class maybe back in high school, something if I can place this thing in a particular form, I can look at it before I start sketching. I can see what the amplitude is, what the how to find the period of the graph right quickly, if I can place it in a certain form. So I'm gonna do it both ways here, guys, on the one I see here. Part one, let's call this part one. Jacob, read that function to me that we plan to sketch.
F of x
Okay, no.
equals, here, I'll wait for you for
F of x,
equals -3 cosine pi over 3 minus 2x.
make sure I have that copied down correctly. Looks like that.
Correct.
Now, if, when you finally see a quiz on this, and definitely you'll see one of these on the final exam for sure. In fact, I think we have one more exam coming up before the final, don't we? Exam 5, so you may see this on exam 5. If I just left it open and say, just sketch, any way you wish. Matthew may say, Professor, I like transformations. Go for it, Matthew, go for it. And he'd say, Professor, I know this right here, it says a reflection through the x-axis. And then he's wise, and he said, wait, Professor, I remember us doing this. We placed the x term first and wrote something like that. And then more than likely he says, now factor out -2 and be very careful. Does this inside here now look, if I have no mistake, look like this? And why do that? Because now, in terms of transformations, this says what? Now reflected also through the y-axis. This says, hold on, you got either a horizontal what? Stretch, and you gotta do it by a factor of?
1/2.
1/2. That's so tricky. 1/2. We did that on a handout way back. And finally, this is what they call a phase shift now, horizontal shift. To the right, what? 5/6. Guarantee you, my students could do it if they had the time. But it would take some time.
No, pi over.
And this right here is a vertical stretch by 3. Now, what's the issue? What's the problem? I took the -2 out. Okay, is that the way it's presented to us? Yes. So guys, if you want to do it through transformations, you could. Let me do a count right now, Matthew. I'm just saying Matthew maybe wants to do it. There's one here. That's one transformation you guys showed me. another one here, that's 2, 3, 4, 5. So this thing has 5 transformations along with the parent graph. I would be here, that would take up all my time I have today with you guys. It's a little lengthy, so I'm not going to do it like that. I want to show you another quick way to get to the final graph without showing me each transformation. Does anyone recall something we may have done? I know I've not seen you guys for a while, that's the problem. That maybe I did to get to the final graph fairly quickly. Jacob, go for it.
Didn't we place the argument that we bound it between 0 and 2 pi? I believe?
We bound that between 0 and 2 pi. Why? Because cosine, I think when I graphed cosine, was the parent graph also caught between 0 and 2 pi.
One cycle.
For one cycle. So I want this one caught between the same bounds. So guys, we'll bound this. By the way, since I cleaned it up a little bit, it may be wise to put it in this form. It's up to you guys, or you can use the black form. So let me use the black. So you're telling me to do something like this, Jacob, with that argument in between 0 and 2 pi. Is that true?
Yeah.
I think I see something that may be happening. I can do it like this. It might be a little bit confusing. Can anyone tell me what might happen if I leave it in that form? I think it might be better to go back up here. We'll see. What may happen if I leave it like this and I'm trying to solve for x? So someone tell me ahead of time before I do it. I think I'm going to go ahead and do it. I've got to solve for x here. What may happen in my attempt to solve for x? The way it's presented.
The less than or equal to will flip to greater than or equal to.
Thank you. I see right now. That's may happen. Let's do this. Let's move that, guys. The pi over 3. Let's move that over. Try to solve this, and we'll move it here. We'll drop that here. And of course, if I subtract pi over 3, I got what? 2 pi subtract pi over 3. Help me out here, guys. Is that 5 pi over 3 remaining?
Yes.
Make sure we follow what we're doing here. So far, so good? I think. Let me make a mistake here. And then, sure enough, you said you're correct here. Divide through by what? -2?
Yep.
And we know what happens for middle school. This is going to be what? Pi over 6, I think. Now, greater than or equal to, he tells me, because I'm dividing through by a negative. This is what, x? Greater than or equal to, and guys, is this a negative? 5 pi over 6, yes or no? Is that what I ended up with? Even though it's awkward, can anyone tell me what might that be telling me to do when I get to my grid? Where should my graph start? And where might it end? And we have to put some intervening points in between also shortly here. But tell me somebody tell me the start points and the ending points. Jacob, go for it.
-5 pi over 6.
Okay, about -5 pi over 6, hang on. So he says the professor down here at -5 over 6, 5 pi over 6. Mark it down here. And I'm going to end where?
Pi over 6.
Pi over 6. Someplace here. Just get some space here. As long as you mark it for me, I'm good. You guys agree? With my bounds? Now, how many points should I have altogether? 5. That's what we have for the parent graph. By the way, let me remind you what those points were for the parent graph. You guys probably know it. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Is that true? So I need 5 points here. Now, does anyone recall how can I discover, because this is acting like 0 on the parent, and this is acting like 2 pi at the end. So I've got the beginning and the end. I need what's conforming to pi over 2, conforming to pi, and conforming to 3 pi over 2. Does anyone recall how we did this? That's the trouble when you have a holiday. I should have had a Zoom session on Monday. I was thinking about it. Should have had a Zoom session somehow in the evening or something on Monday. Okay, does anyone recall? But I need to pick up those 3 intervening points. Isa, do you remember the process I was using?
Did we subtract one from the other to get the?
Okay, let's call that the period. Okay, 5 or 6, the ending, subtract the beginning. If I do my arithmetic correctly here, this is called the period, the ending, subtract the beginning of the cycle. I think it's 6 pi over 6, is it? It's a pi. So now I know the period is pi. Now what should I do with that period for help to get those 3 intervening points I need? Divide by? We divide by 4 altogether. Why 4?
There are 4 quadrants.
4 quadrants. I gotta make sure I cover 4 quadrants here. So if I now divide by 4, I'm gonna call this my spacing number. Space by that period divided by 4. Guys, this is a tough problem. My very first one is. You'll be very careful. Nathan, this tells me then go to the beginning, add pi over 4. Whatever that is, add another pi over 4. Add another pi over 4, add another pi over 4, and you'll finally reach pi over 6. The awkwardness is I'm adding pi over 4 when I see 6's down here. So what might be wise for us to do so it's much easier for us? Matthew?
Equal denominator, in this case 12.
Yeah, let's get, you got a common denominator. The guys, let's call this, 12 here, maybe 3 pi over, 12?
Yeah.
I'm gonna be clever. It's awkward right now. And this, if I want 12, is what, negative 10 pi, is it?
Yes.
Over 12. And I guess this one's what here, guys, 2 pi? Over 12. That's gonna be much easier to space this now. Is that true? Now, if I start adding 3 pi over 12, be careful. I got negative 10 pi over 12, add 3 pi over 12 to it. That takes me up to, guys, I gotta squeeze it in. Where is it? Where is this? Is it negative, how much is it here?
Negative 7 pi over 12.
Negative 7 pi over 12, so you're telling me it's in here somewhere? Yes or no?
Yes.
Okay. Now take that and add another 3 pi over 12.
Negative 4 pi.
Negative 4 pi over 12. This is really getting on my last nerve here. Here we go. We've got a lot of negatives here. We stretch this out. Get this all done here. I think you guys told me what? Negative 4 pi over 12. Add another 3 pi over 12. I'm now where? Negative pi over 12. I think I heard. Now I need one more. When I take negative pi over 12 and add this one more, that makes that what? 2 pi over 12? Which I think was pi over 6 that we had the ending. So let's do 2 pi over 12. I know it looks awkward as you know what. And I guess the axis is over here. Y-axis. It's going to be stretched out like that. Did you guys agree? Okay. Now, please tell me, did we sure enough, this is our beginning, which we said earlier, does this sure enough conform to where we said it should end? So it's the end of pi over 6. I have everything in terms of 12 with Matthew's help. Okay, I got that done. A student asked, when I first presented this, I remember a student asking, saying, Professor, after I do this business, is this done? This is done. You don't have to worry about this any longer. I'm gonna raise it. That's finished. All you need to worry about is this with the cosine graph. Now what does this mean? This means the cosine graph is gonna be what? Flipped over, going upside down, reflected through the x-axis, and you gotta stretch it by 3. Now, here's the beginning. Does anyone recall what the cosine parent graph did at its beginning?
At the beginning that began of.
It was where? Where was it though? What number was it? 1. This one should behave like this, except it should be what? Flipped over? And stretched by what?
3.
3. So I'm going to do this, guys. Does that tell me my graph Anything green, if this green marker will work, is it gonna start here?
Yeah.
And -3. My next point, does anyone recall what the parent cosine graph was doing at the next point?
It was at 0.
It was 0 on the axis. Gotta know what the parent graph looks like. At the next point, please tell me, was it, I think ours was down here, wasn't it?
Yeah, but we flipped it.
Okay, this one should be flipped, so it should be what, up 3?
Yeah.
Takes a little effort here. And that says here, there. Next, am I back on the axis? Yes or no?
Yes.
And finally, at the end, we've done this correctly, I'm right back to where I started. Do we agree?
Yeah.
Connect, please make it somewhat with curves. These are arcs of a circle. Something like that. And you have one cycle of this crazy graph representing that function. Make sense? Okay,
Just one
Matthew.
thing. So, what if because of the negative sign at the beginning, it would be the inverse, meaning it's flipped?
Yes.
Because isn't that the base cosine shape of curving up and down?
No,
No.
the base cosine curves down.
Yeah, you always look at the beginning. The beginning, I think, on the parent graph was up here.
Okay.
Mine's been flipped through the x-axis.
Okay, that's just my memory.
Okay. You guys agree? Now, Jacob, what types of questions did I have about this graph?
Find the period.
Okay, hang on. Guys, the period is the ending of the cycle. I think we've already done it. Ending of the cycle subtract the beginning of the cycle is a pi. That's the period of the graph. The ending subtract the beginning. Okay, what else did I ask?
The amplitude.
Amplitude should be the highest point the graph goes from its axis. Easily seen 3.
The domain.
Domain, now guys, when they ask for domain, they want the domain not just on this one cycle. They want the domain of the function. That means I could pick up here and what, draw another cycle, and another cycle, go on the left, pick up, draw another cycle here. Does it go forever?
Yes.
I just have one cycle. So my domain, all real numbers. Jacob, did I ask for the range also?
Yeah.
-3 up to what, +3?
Mm-hmm.
Now, I'm hoping, when I did this worksheet, what's the next question?
F of pi over 12.
F of pi over 12. Pi over 12, guys, was it negative pi over 12?
No?
No, the F of pi over 12, positive pi over 12. I don't see a positive pi over 12. You guys see a positive pi over 12 on the graph?
No.
Okay, now, let's find out what the value is. Maybe I should do one that's on the graph first to check the graph. Jacob, let's try this. Let's try this one.
Okay.
Let's find f of negative pi over 3. If we plug in and do it correctly, the answer should come out to be by the graph what? 3. So let's find f of, we'll try this one, negative, I'll go ahead and reduce this down to pi over 3. And if I'm careful, I'll go back to the original. -3 cosine, and you want to help me out here, I think the original was like this, pi over 3. Subtract 2 times, what was it? Pi over 3?
Negative pi over 3.
Negative pi over 3.
Am I trying pi over 3 or negative pi over 3?
Negative pi over 3.
Pi over 3. And we'll step back and see if that's what I need. You guys agree? Now, if I do the calculation, I get something other than 3. Something's wrong with this graph. Okay, this is -3 cosine. Guys, inside here is pi over 3. It's like plus 2 pi over 3. You guys will agree with that. That's -3 cosine. Now inside there, is that 3 pi over 3? Which is pi. Cosine of pi from the unit circle is?
One.
Negative
Or,
1.
sorry.
-1. is the x-coordinate at pi on the unit circle -1?
Yeah.
If it is, then a negative times a negative gives me yes. +3, it agrees with the graph. I feel good. Okay, Jacob, I don't think I'm gonna try that pi over 12. We could try pi over 12 and find out what the value is. Same thing I did on this one. You just have to crunch through and find this value there. Okay, I think that's enough there on that. Was there anything else on that handout, just for this particular one here?
There was a note.
Now, if this happens, and this is what the two students emailed me about this. If I make, put this back in here. This, take the form of one of those at the bottom there of that part. Tell me what the first one looks like. Tell me the one that has the cosine in it.
The cosine?
Yeah.
Oh, y equals a cosine b theta minus d.
Mine's D.
Yes.
Guys, and I think this class could do it. Can I somehow make this, it looks like, pretty much looks like it now. Can I make this look like this?
Yeah.
If so, they're telling me, I think, did I identify what the A, B, and all that business was? The A is what? The amplitude?
Uh-huh.
And I think I gave you something with the B here.
The B.
On the period, if you know what the B is. The period is equal to what? 2 pi over
b.
B. And this is what they call a phase shift. We call it a horizontal shift.
Phase shift.
Yeah. Look at all we've done just on one problem. Now, help me out, guys. Can I make this look somewhat like this?
Mm-hmm.
If so, maybe I can identify a few things here. Okay, how close are we? We want theta subtract D. Help me out.
Oh, we want theta subtract d, which means that we should have -2.
Okay, let's put, does that -3 stay where it is?
Yeah, -3 cosine. And then we have that -2, which is gonna be the b, so it'll be negative.
Hang on, you got -2 here.
Yeah. And then x minus pi over 6.
Over 6. Now let's see what's gonna happen here. Nathan,
Yes, sir.
does that A, I know there's a negative sign there, but does that A correspond with amplitude? Was
Yeah.
the amplitude short enough when we identified the amplitude over here? Was it short of 3?
It's 3.
It's always positive. The amplitude is always positive. Distance. The next one's where it bothers me. They're telling me I can find the period if I take 2 pi and divide it by B. And guys, I'm gonna count B just as a 2 there from that negative sign. But those cancel out. Did we get a period of pi ourselves when we discussed pi, period?
Yeah.
So it's 2 pi over B, and that B, let's make that B positive there, to make it work out. Phase shift, we said the phase shift should be what? Pi over 6, I'm looking for this. Where are we phase shift? What do you think phase shift is?
d.
And they call it D. What might that correspond with the way we graph this?
In this case, it's where we ended our graph.
Did we end here
Yeah,
at 5 or 6?
but I think it might have changed because of the -2.
It could have, absolutely. But they're saying that D has something to do with the phase shift, and then he says, looks like I showed up, we ended the graph at 5 or 6, and they say 2 pi over B, oh no, it's just D there, yes.
Why when you calculate D, why did you use the negative?
And they want you to use positive, write yourself a note there. Make sure that A is always positive and the B is always positive. Okay. All right, good question. I just want those to all be positive, so all this will work out. Guys, now if you want to take the time to do this business and try to calculate period, amplitude, phase shift, and if that would help you at any at all, to then start graphing, go for it. So if you have the patience, you can play around with it and put it in that form on the handout and then work with it and find the period and amplitude and so forth. Now, Jacob, trying to finish this up. I think the next one, I gotta be careful of this. What trig function is involved in the next graph?
Cosecant.
And I have not even shown you what the parent for cosecant looks like. Did I get a chance to show you guys tangent last
Yeah.
week?
Or, no.
I did sine and cosine, I didn't do tangent, did I? Okay, I've got to show you what the parent graph for tan looks like, or you can't do a function with a tan involved. I gotta show you cosecant, and I gotta show you secant, and I'm gonna leave cotangent up to you. It's in the textbook as to what that graph looks like. I'm gonna do first, since I have not done it yet, let's go to part 2. Say, let's sketch. I'd like to know just what this may look like. You guys, I'm gonna call it y is equal to tan x. I want to see what a parent graph looks like on for tangent. Let's go to the grid. And I think the best approach here to get it done fairly quickly is this. Guys, let's go back to the unit circle, go real quickly right here, and ask you guys to help me. I want to know this tonight on the exam, this part. Remind me on this rough sketch. Real rough. This corresponds with 0, and I think the ordered pair was 1, 0. Is that true? We'll do mine in radians. This corresponds with what? Pi over 2?
Which is 0.
0, 1. Pi?
0, or negative 1.
Negative 1,
0.
0. 3 pi over 2 down here.
0.
And 0 what? Negative 1?
Yeah.
And then of course you make one complete revolution right back to where we started. That's the unit circle. We did that. Now I'm doing tangent. I know I put an X in there. I think maybe I should do this so you won't be confused. Your textbook uses an X. Let's call it theta. I'm doing tan theta. Now, what's the definition for tangent?
Sine over cosine.
Well, something else. I can use sine or cosine.
Y over
More
X.
basic. Y over X. It says if you wish to graph tangent, go to each one of these critical numbers and place Y over X. Now, that means on my grid, I'm gonna start up at 0, pi over 2 on the x-axis, pi, 3 pi over 2, and 2 pi. Anyone tell me if you place Y over X at the very beginning at 0, you're gonna end up with 0. Aren't you? Y over X, 0 over 1?
0.
Don't scare me. If I go up to pi over 2, Y over X, you'd be placing what? 1 over
0.
0. Now that's an undefined. So that means I'm gonna have an asymptote to show there's an undefined there. Next point is pi, which is right here. I place Y over X, you're placing 0 over a negative 1, is that 0? 3 pi over 2 is down here, Y over X, negative 1 over 0, another undefined, and I have this. Another asymptote. Finally, 2 pi, take me all around to here. Y over X, what, 0 over 1? 0. Now, am I supposed to connect those 3 points and say, oh, it's a straight line? Well, of course not. You got asymptotes to worry about. Now, I got to do some really good thinking here with you. This piece right here, this little interval, is quadrant 1. This from pi over 2 to pi on my grid here, that's quadrant 2. From here to here, represented here, that's quadrant 3. And finally, this is quadrant 4. If anyone tell me back at quadrant 1, does anyone think they know what tangent, Y over X, in terms of a sine, it's guaranteed to be if you place a